June 2015, Part 4, number 37. This question is worth 6 points, so there's a lot of information that needs to be developed, and there's also many facets of questions in order to answer. A football player attempts to kick a football over a goal post. The path of the football can be modeled by the function h of x is equal to negative 1 over 225 x squared plus 2/3 x, where x is the horizontal distance from the kick and h of x is the height of the football above the ground, when both are measured in feet. On the set of axes below, graph the function y is equal to h of x over the interval 0 through 150, including both of those values. So there's a lot of things to think about. The first thing you have to recognize is that you have a quadratic equation because we have x squared in this equation. It's very important that when you put it into your calculator, you do that correctly as well. Make sure you put the negative sign first, control divide for the fraction, 1 over 225, and make sure you click the cursor to the right in order to get out of the fraction before you hit x, as well as x squared. Then plus, control divide, put the 2 over the 3, hit the cursor to the right, and put x outside of the fraction. It's very easy to end up with the x down in the denominator because you didn't hit the cursor. Sorry for the birds chirping, but I can't get them to stop. They're outside, so try not to pay attention to them. The next thing you have to consider is your interval. This is your restricted domain. So on your calculator, you're only going to get a small picture, like this portion of it, because it's on automatic settings. And as you know, you're only at like 6.67 and 6.67, and also for the negative values. So we need to expand it all the way to 150. So I'm going to show you how to do that in your calculator so you can get a nice picture. So this is the original picture that you will get when you do put this into the calculator. And if you take a look down here, this is what I mean with the fraction. You have to have the variable on the outside of the fraction because it's very easy to have it in the denominator. And if you do that, then you won't have a correct graph. So I'm going to put this off to the side. So the next thing that we need to do is to change the window so we get a nice picture and we don't get the one in the first calculator diagram that I have here. So you're going to go to, or select, you're going to hit menu first. Then you're going to select 4, window zoom, and then 1 for window settings. So you're going to change your window settings for your Xmax. Your domain is restricted to 150, but I'm going to go 10 more than that, just so I can get a clearer picture. You never want to use the exact value. You want to do a little bit more. I changed the X scale from auto to 10. I left the Y min and X min, and I changed my Y max to 75 because I took a look at the table and I saw that I had some larger values there. 75 might have been a little bit too much. You probably could have gone with 60 or maybe even 50, but I chose 75. That's my own preference, and I changed the Y scale to increment every 5. So the X scale I incremented every 10, and Y scale I incremented every 5. So go ahead and do this and play around the calculator because it's up to you to be able to manipulate the window based on your table in order to get a clearer picture, and that's a skill in and of itself. So it takes practice in order to develop that skill. And here's my picture that I get. And as you can see, I have a nice parabola, which is expected because I have this x squared. Okay, now I can answer some of the questions and go ahead and graph as well. So my x values, as you can see, my domain, I've got it between 0, which starts here, and 150, and I have my range, my y values, up to 60 at this point in time. I think that would be good enough, even though I have it up to 75 on this picture right here. And when you go to the table, you don't have to graph the decimals. Just do the nice whole numbers. So these are the graphed points, and I can see that the vertex, or the maximum, which is the highest point of this parabola, is right here. I'm going to go ahead and connect all these points now to the best of my ability. And there it is. Okay, determine the vertex. H of y is equal to h of x. I already mentioned this earlier. This is the value 75, 25. And when we interpret the meaning of this vertex, which is what we're asked to do in the context of the problem, this is the highest point of the football when it's kicked. Or the maximum point. The goalpost is 10 feet high and 45 yards away from the kick. Will the ball be high enough to pass over the goalpost? And justify your answer. You really have to look deep and hard at this value here. They give you a goalpost that is 10 feet high, which is y, but they give you x in terms of yards. They tried to trick you there. So you need to convert the yards into feet. If you look at the back of your Regents booklet, you need to take a look at your reference sheet in order to do this conversion. So here's the reference sheet. We need to convert yards to feet. So we're going to take a look at this right here. Since we have 1 mile equal to itself 1 mile, we can set what they're equal to in feet and yards equal to each other. So I have 5280 feet equal to 1760 yards. I know that I have 45 yards, and I'm looking for the number of feet. You're going to cross multiply in order to solve for x. The only thing you're going to multiply actually are these two, and then divide by this. So x is equal to 45 times 5280 divided by 1760. And we get 135 feet. Now going back to the problem, it would have been nice if they put x first, which is the 45 yards, and then y second, but they organized it so that y is before the x in this problem. So that's another tricky thing that they applied. So our coordinate now in terms of feet is 135, comma 10 for height. That's our y value. Height is always y. Let's see if we can answer this question. Will the ball be high enough to pass over the goalpost? Justify your answer. So when I look at this coordinate, 135, 9, okay, the height is 9. So if this height is 10, the answer is no. The goalpost is too high for the ball to be kicked over, okay, because the ball had a height of 9 at 135 and the goalpost is 10 feet, so it would not make it over the goalpost.